Okay, so let's start separable equations. So the idea is to use our algebra skills to separate the differential and then integrate both sides. That's the big picture. Big picture idea. Okay. Here's a definition of a separable equation. So a first order, and this is only mainly for first order ODEs really. Of the form dy dx equal to g of x over g of y is said to be separable. Okay. So I think we can go straight into the examples I can show you. It's pretty straightforward. Yeah, here we go. It's example 1 from the book. So solve 1 plus x dy minus y dx equals to 0. So the goal is to have something in terms of y, dy on one side and the other, and then something in terms of x and dx on the other side. Right now, you notice how they're mixed and matched, right? So let's see if we can. So what I'm going to do is start by subtracting or adding the y dx to the other side. So I get 1 plus x dy equal to y dx. Currently, I can't integrate anything because this needs to be in terms of x and x. So what we're going to do is divide this over here and divide this nonsense over there. I skipped an algebra step. Do you guys see how we got there? If you don't, let me know and I'll redo this step. Is this okay? All right, I'm assuming you're good. If not, just tell me. No big deal. The goal is to have f of x dx equal to g of y dy, which now we have that, right? We have 1 over y dy equal to 1 over x plus 1 dx. This is the same thing, of course. So I turn that off. Okay. So at this point, you just integrate both sides. And no big deal, right? This will simply be an ln equal to ln of x plus 1. Plus, of course, your c here, which we'll call c1, I guess. Now, I skipped a substitution step for integration. You guys comfortable going from here to here. Any questions on the integration? You can do a U, this one would technically be a U sub. This is just definition, right? Integral of 1 over anything, 1 over y is always ln y. This would end up being the same when you do a basic sub. Now, so what we did is solve the differential equation, but it needs to be in terms of y. We're solving for y, not ln y. So now at this point, you need to cancel the ln. So what you do is you exponentiate both sides like this. Cancel your ln and e, and then it leaves you with y, or absolute value of y, but of course, that's simply going to be just y, right? This right here is going to be the same as e to the ln x plus 1 times e to the c. So this will become, right, these will cancel, leaving you with absolute value of x plus 1 times e to the c. So what we're going to do here is just let e to the c 1 equal c2, because it's arbitrary. Anyway, it's some constant, right? So in order to remove an absolute value, you end up getting two different solutions. You get y equal to plus or minus c2 times x plus 1. Some people might leave the e here, but this is better because this is a constant. So why not just rename it as a constant, some other constant? Anyway, any questions on the algebra step, the integration step? Or the this algebra step here? You guys okay?
Just with the answer, would they want it to be an absolute value for the x plus 1 still, or would you just leave it in parentheses?
Well, I mean, this is the same.
Oh yeah, true. I didn't even think about the plus minus, honestly. I wasn't even paying attention to it.
No, you're good. But by definition, this is fine. You could, I mean, on an exam, I'd be cool with this, but on the homework, I'm not sure. They should specify.
Oh yeah, I just know WebAssign's weird sometimes with the absolute value and stuff.
Yeah, they could be. I guess we'll see. Let me know what if they're weird about this.
Yeah, I didn't pay attention to the plus or minus, honestly. For some reason, I was just staring at the.
No, you're good, man. Don't worry about it. You're good. So overall, makes sense. Before we move on to the next example, if you guys are good. Okay. I don't want to make assumptions that you guys are all pros, so please tell me if you're struggling with something. You guys cool on that page? I'm gonna turn back if you want. Let me know. Okay. Now that C, solving for C, which we'll talk about. I don't know if it'll come up in this section. Let me see. I guess it kind of will. We'll determine a specific solution for that. Let's talk about that here in example 2. And we'll talk about that in 2.1. I started 2.2 because it helps understand why we care about 2.1. Okay, so solve the initial value problem, dy dx equal to negative x over y. Y of 4 is equal to negative 3. So this will give me a specific solution, okay? That'll solve for C. So let's see if we can solve for this using separable variables technique. So I'm going to multiply the y over here and the dx over there. That'll get me to y dy equal to negative x dx. Okay. You guys cool with this step? Then at that point, integrate both sides. Doesn't matter where you put the x or the negative, sorry. So this will give us y squared over 2 equal to negative x squared over 2 plus some constant, plus c1. If I move the x squared over here, what type of equation would this be? What type of graph is this?
It becomes a circle.
Yes, it's a circle. The solution of this OD is a circle. And the C1 is going to be what for the circle? You remember?
I believe it's the radius.
Yeah, so we're going to have a bunch of families of solutions that pertain to that radius. So let's look at that visually. Okay. All right. Okay, so C2 can be, or C1 can be whatever. It all depends on the initial condition. So if it's 1, we get that type of circle. If it's 2, we get another solution. If it's 3, so we can get all kinds of solutions depending on the condition, okay? So let's see what C1 will be. So they said that this step here, use y of 4 to find, this, use this point, I guess I should say, 4 comma negative 3. So that means, so plug this in, solve for C1. So we're gonna have 4 plus negative 3 equal to C1. So what will this be? That's 8, right? Plus 9/2. Maybe I'll leave that as a 16 instead. So 16 plus 9, it's 25/2, right? So our actual solution for this example will look like this. So this is the solution set for y of 4 comma negative, or 4 comma negative 3. And the actual solution, you would write it this way. Any questions on this example? Okay. You guys cool on this page then? Okay. This next one will be maybe a little difficult, but the topic is about losing a solution. Let's see how that happens. So this technique requires partial fractions from Cal 2. So let's see what happens. If I multiply by dx on the right, divide by that nonsense over here, I get this, right? Then we factor the bottom. That's a difference of squares. So the right-hand side is easy to integrate. This is going to be partial fractions. Okay, so what we're gonna do, we're gonna focus on this left-hand side here. So 1 over y plus 2. Actually, this is what we'll do. We're going to completely avoid the integration and just focus on the algebra here. And then we'll come back to this. So we must use partial fractions. So 1 over y plus 2, y minus 2 is equal to a over y plus 2 plus b over y minus 2. You guys remember doing this? Then you multiply both sides by the LCD, which will get you to here. Let me show the work this first time at least. The LCD is y plus 2, y minus 2. So this cancels, right? All these are gone. On the left-hand side, this cancels one of them, leaving you with a times y minus 2 plus b times y plus 2. Any questions on this partial fraction step? Okay, so distribute the A, distribute the B, or if you prefer, you can use the Heaviside method for easy questions like this, but I'm going to use the technique that always works just in case you have forgotten how to do this. So gather all the y terms and constants together. So here's ay plus by minus 2a plus 2b. So you factor the y out and you're left with this coefficient. And here's my two constants, who cares? So you create a system by equating the coefficients, right? We said a plus b, there's no y coefficient on the left. So a plus b is equal to 0. There's two constants, and there's a constant equal to 1 over here. So this constants are equal to 1. At this point, use a matrix or a solver. I don't really care how you solve for a and b. At this point, I believe you have done this already. You have solved the matrix before. You should get 1001 on your calculator or by hand. And the solution will be 1/4 and -1/4. Okay. You guys cool on the partial fractions? I went through a little fast since you guys had no questions. I'm assuming you remember it. You remember the how to do so. One moment. Okay, so now we have solved for it. So we can separate this fraction into a and b, and it'll be an easy integral. They'll just be logarithmic integrals. So currently we were about to integrate and we took a side step for this here, right? So back to integrating. Okay, 1 over, oh, actually it was just dx over here, right? That's right. So right before you integrate, you solve for the partial fractions. I believe a was over y plus 2, right? Yeah. So you got 1/4 over y plus 2 plus -4 over y minus 2. All this nonsense dy. We can go ahead and integrate this side. That's going to be a simple x. So this would be 1/4. Integrate this first piece. That'll be 1/4 ln y plus 2 minus ln y minus 2. Oops, forgot the fourth. Equals to x plus c. So some simple U subs, or you can kind of see what's going to be. You don't really have to do the sub, but this works because of substitution. Any questions on the integration? Okay. So at this point, we have finished with the integration, but we have to solve for y if possible. It might not be possible here because the solution looks kind of messed up, but let's try and find out. So you're doing our log skills, right? Number one, let's get rid of those fractions because they just look annoying. Multiply everything by 4. We'll get here. Much prettier, right? And 4c, but we'll just let c equal 4c equals c1. Who cares? And the next step, I'll replace it. Combine those logs, we get ln y plus 2 over y minus 2 equal to 4x plus c1. So it's looking a little better. Use e on both sides, right? Y plus 2 over y minus 2 e to the 4x plus c1, y plus 2 over y minus 2 comes right out. This can be replaced like earlier. So let e to the c1 equals c2, just because I don't want to keep writing that nonsense. Okay, yes, cool in the algebra so far. I'll wait a moment just in case. Okay. So now the question is, can I isolate y? Maybe. I'm gonna multiply y minus 2 on both sides. So I got y minus 2 right here times this. I'm gonna call this now C2E4x, right? So distribute this. Let's see. Well, let's see, there's a shortcut before I get too crazy with this. Yeah, let's find out. Let's just go with it. Y plus 2 is equal to y c2 e4x minus 2 c2 e4x. I'm going to let 2c2 equal c3. I'm going to move this y over here, get all the y's together. Looks like maybe I can solve this. Subtract that 2 over. -2. Oh, actually, yeah, that's this 2. This one will be maybe I'll leave it as is for now before I confuse it all. -2 C2 E4X. Okay. So factor the y. That gets us to 1 minus C2 E4X equal to factor that -2, that gets us to 1 minus C2 E4X. Okay. Is that correct? Yeah, looks good. Cool. So y will equal -2 times 1 minus C2 E4X over 1 minus C2 E4X. Interesting. Do you see what happened? So it appears that it'll cancel out. And y will equal to 2 or -2 because C2s can determine the sign of this guy. Or I can multiply that in there. I mean, it really depends. You see what I'm saying? Like I can let C2 be something specific. It really depends on what's happening. So one of the solutions will be plus or minus 2. But that solution was not clear until we isolated y and did all the solving of the ODE. But anyway, any questions on the algebra integration or solving for y there? Okay. This making sense so far? Hope. Okay. Let's do an initial value problem. So solve e to the 2y minus y cosine of x dy dx is equal to e to the y sine of 2x. Y of 0 equals 0. Okay. So as you can see, these problems get more and more complex, and they just require, your Cal 2 skills, right? That's what it's going to come down to. So right now, we need to use our algebra to isolate x and dx, y and dy. So I see a dx here, so I'm going to move this dx over there. Keep that dy there. So let's start with that here. E to the 2y minus y cosine x dy equals to e to the y sine 2x dx. So first step, multiply both sides by dx, right? Next step, divide both sides by cosine to get this x stuff over here, and I'm going to divide both sides by ey to get it over there. Okay, so e to the 2y minus y over e to the y is equal to sine 2x cosine x dx. So divided cosine over here, divided e to the y over there. Okay. All right. So let's simplify this left side first. Divide both pieces by e to the y. This will become e to the y minus y e to the negative y. Yeah, so this will cancel one of those two. And here I just moved it on up there times multiply by the y there. Stop me anytime if you feel like you missed something. Sine 2x is a double angle. So do you guys remember the formula for sine 2x? What is a double angle formula? I'm gonna send you guys some trig identities just in case. Anyway, sine of 2x or 2 theta is always going to be 2 sine cosine over cosine. So that will allow us to cancel that guy. Okay. So now we just need to integrate e to the y minus y e to the negative y dy equals to the integral 2 sine x dx. To this side is no big deal, right? That's just going to be -2 cosine. This first one's no big deal. That's just itself. This will require integration by parts. Okay, so I'm going to get e to the y for the first part minus the integral of y e to the negative y, which I'll do that in a second, -2 cosine x plus, I don't know, I'll just call it C1, I guess. So do by parts here. So that'll be minus, so I'm just put this in parentheses, I'm gonna be working in here. Integral of u dv is going to be, let's do the little formula over here. U will be u will equal y, dv will equal e to the negative y, du will equal dy, v will be negative e to the negative y. And the integral, the formula that I'm about to use is this guy. U dv is equal to u times v minus the integral v du. Any questions on by parts? Do you remember how to do integration by parts? To multiply u and v, that'll be, make this a bracket instead. What was it? Oh yeah, u times v, so that'll be y times negative e to the negative y minus the integral of v, which is negative e to the negative y, du, which is dy, equals -2 cosine plus C1. Then that part's still there. You write that prettier. So -2 cosine x plus C1. So e to the y minus a minus, that'll be plus y e negative y. Negative negative would be plus integral e to the negative y. Minus 2 cosine plus C1. E to the y plus y e negative y minus e to the negative y equal to -2 cosine x plus C1. All right, finally, there we go. So we applied the by parts on this piece here, and then finished it off there. And now we are done with integration. So let me add some notes here. So simplify and isolate dx and dy. Here to here, we did integration by parts. All right. Any questions up to this point? So they gave us an initial condition of y0 equals 0. So we're going to use this to solve for C1. So plug in 0 everywhere because they're both 0. So that'll be 1 plus 0 minus 1 equals to cosine of 0 is 1. So that'd be -2. So these are gone. So 2 is equal to C1. So put it all together and our solution is this. I don't know if I can make it any prettier. No, I guess not. E to the y plus y, e to the negative y minus e to the negative y equals -2 cosine x plus 2. So that is your solution. Once you have the initial condition, you have a specific answer. This guy cannot be solved for y. Well, actually, let me see. Yeah, that's it. Sorry. Any questions on example 4?
The integral of the e to the negative y, wouldn't that just be itself and not a negative?
This guy
Down one,
here.
that one right there, because I'm looking at a textbook and it says it's a plus, not a negative on the next line.
Oh, let's see. Oh, maybe. Let me check. It becomes a plus because it's double minus. That minus came from the integral. When you integrate e to the negative y, it will be negative. So this will be positive, which will then be negative again. Let me check the textbook. Okay. Yeah, I see what you're saying, but let's double check our work. Why is it negative? This started out as negative, so that's fine. This guy divided, stayed negative by parts. Here, I pulled the negative out and did not use it. So that's from, that was the mistake right there. Because if I'm not using it, why is it here? So then this times this would be minus. So there should be, yeah, I just kind of stopped writing that bracket. That's kind of what caused problems. see. So this becomes plus, but then this goes to negative. They should both be positive. All right, one moment. Pause this and figure out the issue. All right, so what we missed was I did not use the negative sign here. It should have been waiting outside the entire time. This became positive and then negative again because of the formula, and then negative again because of the integral. Okay. Then this guy will switch them both to plus here. To the y. No, this one remains negative. I do not see an error here. Let's double check the book. Something strange is happening here. So this is right. Minus, minus. Pull out the negative. So U and V. Oh shit, that's so stupid. Yeah, that was supposed to be minus here. Okay, there it is. We're good now. Too many minuses is what it was. Okay, so start over. Factor the negative out, so that's completely ignored. This is U dv. U is there. V must be found via integral. Integrating here gave me a negative e to negative y, so this is uv minus the integral of v du. V has a negative on it. Du is equal to dy. Minus minus is a plus. Integrate that gives me a minus. Double minus from that minus outside makes this all plus. There it is. Sorry about that minus error. Any other questions on this? Alrighty. Let's see how much time we got. We have a little time left. You guys had any issues with any of the problems we just discussed? You guys have any homework problems you're struggling with right now? Or you think, or maybe it's a ridiculous question I forgot to delete. Okay. All right, then I'm gonna have 2.1 is about directional fields, which is more of a conceptual section. There's not much actual solving. So now that I have some free time, I will record this tomorrow morning and upload 2.1. That way you got 2 extra sections. And the next time I see you, we will do 2.4, I think is next. Let me check. 19 on 1.1. All right, hold on. Yeah, we'll do 2.3 probably. Yeah, that's not too bad. Okay, let me open the homework. We have some time left. One 1.1, right? Okay. It was the final linear second order differential equation for this guy. Okay. For which this is a solution. One moment. Which y is equal to 1. Oh, I see. Okay. So basically they want you to kind of like, I mean, it's not a very proper solution, but they're trying to tell you, try to guess a solution that once you take 2 derivatives, you end up with it equal to 0. Let me see. It's this one, right? This one here.
Yes, that's the one.
What was your power? Do you remember?
Mine was to the 5th, if I remember correctly.
To the 5th, okay. So let me. I don't know if we have enough time, but. So for the 5th, it's simply this here. So true parameter solution. All the questions beforehand were just verification, correct? Until this one, for the most part.
I believe so. That or just solving for M. This one, I wasn't quite certain how they were backing this one out of it.
Yeah, we
How
didn't
they-
really talk about this. Yeah, I wouldn't worry about it. If you're curious, I'll send you an email as to what they wanted, but yeah, I'm gonna remove that question. Don't worry about that guy. I did not mean to assign that. Let's see here. Prime. Yeah, I was kind of wanted you to guess your way through it, and I think that's kind of dumb. Yeah, it's gone now. If you refresh, it should be gone. Anyway, we don't have much time left. But yeah, if you want to send me an email, I'll send you an explanation later. But if you don't care, then don't worry about it. We'll move on from. We're gonna remove that one.
Okay.
Okay, so yeah, I'll try to post some more lectures tomorrow morning. Okay, I'll post this today. I will adjust the dates a little bit. I'm still kind of building as we go, so nothing's very concrete right now. But I would like 1-1 and 1-2 to be done soon, because I do want you to start focusing on 2-2 and 2-1. No longer worried about 1-3. I'm hoping you got my message. That would be extra credit. If you want to do it later, that's fine. I'm going to remove its due date, but I would prefer you first get 2-2, 2-1 done before you do 1.3, because you will have a ton of, you'll for sure have exam questions on 2-2. I'm not going to test you on 1-3.